Okay, hi everybody. Sorry, I don't know why I started with okay. Welcome back. Today we are going to do not Unit 6, Day 5. We're going to do Day 5, or sorry, Units. Wow, Miss Scully. We're going to do Unit 5, Day 4, which is about graphing linear inequalities. So we're going to go ahead and start this. This is kind of like a lesson that you need to know before we can do systems of inequalities. So we'll do this, get a little practice, and then we'll go into systems next time. But let's go ahead and get started. I'm going to keep it not on full screen, this stuff, because I'm going to use some of my handy dandy tools at the bottom as we go through. Okay, so let's start with vocab. A linear inequality or linear inequalities are just inequalities that are written with two variables, an x and a y. They are very similar to linear equations, where you're going to see a lot of stuff that looks like mx plus b. The only difference is, instead of an equal sign, it's got an inequality. Now, solutions to linear inequalities, just like solutions to linear equations, are ordered pairs that make the inequality true. Okay, so it's an x and a y that you can plug in for those variables, where when you simplify, it actually comes out true. Difference between equations and inequalities, so these two numbers don't have to come out to be equal, they just need to come out to be true. So when you simplify, if you get 4 is greater than 2, that's a true statement, okay? Now, also with inequalities, with any inequalities, you're probably going to have more than one solution. When we say x is greater than 3, there are a lot of numbers that are greater than 3 that can work to make it true. Same thing with linear inequalities. There are a lot of ordered pairs that we can plug in to make it true. You're not going to be able to just write one or list all the ones that work. Instead, we go ahead and we graph the inequality. A graph will show us all the ordered pairs that work. So, to graph linear inequalities, it's very similar to graphing linear equations. However, because the y could be equal or not equal to it should be greater than or equal to, or less than or equal to, or whatever, we use either a solid line or a dashed line. So, because we're not saying, oh, y is equal to all this stuff, because it could also be just greater than or less than to it, we use a different kind of line. So solid line means that we're equaling these ordered pairs on the line, where a dashed line means we're not equal to these ordered pairs. So the ones that are on that line wouldn't be a solution, okay? And also because it can be greater than or equal to, or less than or equal to, or whatever, with the inequality sign, we use shading either above or below the line to represent all the solutions on the graph. So this is a lot of information. It kind of sounds weird. It'll make sense once we do a problem. Okay? So just a reminder for you in an easier way than all these words, with a solid line, or we use a solid line for our graph, our picture, when our inequality has either less than or equal to or greater than or equal to. So it needs to have this equal to part. The line's going to be dashed if it's just less than or greater than, no equal to part. Okay? We shade above the line to show all of our solutions if the inequality was a greater than or equal to or just greater than. We shade below if it's just less than or equal to or just less than. Okay? Let's go ahead and I can walk you through the steps. Okay, so steps to solving graphs. Sorry if I stopped and started a weird thing. I paused the video. Anyway, so 4 steps. Step 1, get y by itself. Make it look like y equals mx plus b. Because when we have that, we know how to graph that. We can graph the y-intercept and then graph the slope. Step 2, graph the line using the slope and the y-intercept. Okay? Step 3 is figure out if that line is supposed to be solid or dashed. So look at the inequality symbol that you had when you had it in slope-intercept form. If it's an equal to kind of inequality, it's solid. If it's dashed, if it's not equal to, you need dashed, which with your pencil, just go over and kind of erase marks off the line so it looks like dashed. Okay? And then you're going to shade above or below the line. So if it's greater than, you're going to shade above that line. If it's less than, you shade below the line. And then don't forget about our special cases. Remember, using Hooy-Bucks for vertical and horizontal lines. All right? Because you will probably have to graph those as well. More vocab because I forgot to put it on your notes. So please write these in somewhere on your notes. Okay? The half plane is a part of the coordinate plane that it's shaded. So once you shade something, the half plane is the part that has all your solutions in it. The boundary line is the line that separates the shaded from the unshaded part. So it's basically the line that you graph, the y equals mx plus b line. Okay? Example 1. So we're going to graph 2x minus 3y is less than 12. Alright, so the very first thing we need to do is get this so it's y by itself. Okay? So I rewrote it over here. First thing I'm going to do is get rid of this x by subtracting 2x from both sides. So now I have negative 3y is less than negative 2x plus 12. So now I'm going to divide everything by negative 3. Okay? Now, remember, with inequalities, we have that special rule. If you divide both sides by a negative number, you have to flip the sign. Okay? We're dividing everything by a negative number, so we have to flip our sign. So now we have y is greater than, this reduces to be 2/3 x, and this reduces to be minus 4. So that is my slope-intercept form. Right? I'm going to graph the line of negative 4. I'm going to plot that first. Negative 4. Oh, well, there's the whole line. My points don't want to pop up. Negative 4. And I'll go up 2 and over 3 to plot my next point. Now, the reason I have a dashed line here and not a solid one is because it's only greater than. It is not equal to. Okay? So that's why I have a dashed line. The last thing I need to do is the shading part. Okay? So this says y is greater than everything. So this is really important. You can only figure out your shading for above or below the line and after you've gotten y by itself, because otherwise you could flip the sign, something could happen, and you want to wait until you're done. You have something graphable. So now I have greater than. That means I'm going to shade above the line. So here's the line. Below the line is down here, but I don't want to shade that. I want to shade up here, everything on top of the line. So I'm going to use the highlighter, and I'm going to do this. I'm going to shade every point that is on this side of the line is a solution to my inequality. Okay, meaning all of these ordered pairs here, I could plug into the inequality and it would work. The only ones that wouldn't work are the stuff down here in the unshaded part and the points on the line. Okay, they would not work because if I plug those in, I would get something like 6 is greater than 6, which is close, but it's not true. If it was an equal to kind of inequality, it would be true, and that's why it would be solid. Okay, so now you guys are going to try this one on your own. Get y by itself, graph the line. You have a graph on your paper, don't worry. Graph the line, figure out what kind of line it is and where to shade. And we'll talk about what that looks like next class. Okay, example 2 gives you a picture of it and asks you to write the equation of the graph. So to write the equation, not only do you have to find the b and the m like you would for, or sorry, not an equation, you have to write an inequality. Why did it say equation? Not only do you have to find the b and the m like you do with an equation, but now you also have to use the shading and what kind of line it is to figure out what kind of inequality you have. So if you look at it, the y-intercept is 2. And my slope, I'd actually go up 1 and over 2 to get to the next point. So my slope is 1 over 2. This graph is shaded above, which is kind of important. And I also have a dashed line. Okay? So the shaded above means it's either greater than or equal to. The dashed line means it's not equal to. So the only inequality sign that I can use is greater than. Okay? So I just write it with like y equals mx plus b, but instead of the equal sign, I write the greater than sign. So that's my inequality. Y is greater than 1/2 x plus 2. You guys are going to try this one on your own. Okay? Last one, this is a special case. So we have to graph x is less than -2. So whenever we just have one variable and not the other one, it's part of Hoy-Bucks. So when it's x equals or x is less than greater than whatever, it's just x, that means we have a vertical line going on. Okay, that's the x is part of the bucks, v stands for vertical. So we're going to draw a vertical line through when x is -2 right here. Now this line that we're going to draw is not equal to, so that means we're going to have a dashed line there. Okay, so that's my vertical line where x is equal to -2, but we need it to be less than -2. So we need to include all the points that are less than -2. Which side of this shows all the x values that are less than -2? Well, that would be this side right here. All of these ordered pairs have an x value that is less than -2. So all these ordered pairs on this side would be solutions to that inequality. Okay? Ooh. All right. And then you guys have to do this one on your own. You have to graph y is greater than 0. So if x gives you a vertical line, y would give you what kind of line? I would go through that number. You just have to figure out where to shade and what kind of line. So give that stuff a try. I think that's it. Yeah. If you guys have any questions, please, you can use Remind 101. You can send me an email. You can write it down, and we'll talk about it next class. Okay? Otherwise, I will see you next class. And you have a quiz next class on systems of equations. Okay? So make sure you study all 3 methods, graphing, substitution, and elimination, and you should be good to go. Okay? Quiz next class. Don't forget. I'll see you guys later. Bye.